All right, so 10.2 is all about arithmetic sequences. So far in our journey with sequences, we can write a sequence, we can define a sequence recursively, we can even use summation notation to write the sum of the first n terms of a sequence. And then this lesson is dedicated all to a specific type of sequence called arithmetic sequences. So consider this one that you see right here, 3, 5, 7, 9, 11, dot, dot, dot. What do you notice about this sequence in particular, if anything at all?
All odd.
They're all odd? Yep, what else? Rachel? Yeah, they all go, if you add 2 here, add 2 there, add 2 to that one, add 2 to that one. Notice that stays constant throughout the sequence, right? That's the defining characteristic of an arithmetic sequence. So for us, the definition for arithmetic sequence is a sequence with a common difference. So what do I mean by common difference? Well, this is the first term, this is the second term, this is the third term, this is the fourth term, yada, yada, yada. Okay, so if I were to take, for example, the fourth term and subtract off the previous term, which would be the third term, 9 minus 7 would be 2. That would be a positive difference of 2. So if I took the third term and subtracted the second term, 7 minus 5, that would be 2. That stays constant throughout the entire sequence. So any sequence that has a common difference is defined to be arithmetic. Now, that means that arithmetic sequences are recursive. And what does recursive mean again, you guys?
They rely on the one in front of them.
Yeah, they rely on the one before them, right? So that means that if I was going to write the next term of the sequence, a sub n plus 1, it would have to equal the term before it, which is a sub n, plus this common difference d. So this is the generic way that we think about arithmetic sequences. We take the one before it, and we add on what the difference is. In this case, the difference would happen to be 2 for the sequence that I just gave you right there.
Wait, is that d sub?
All right, here is a sequence, a sub n equals 3n plus 5. What I would like you to do is write out the first 5 terms of the sequence. So write out the first 5 terms, a sub 1, a sub 2, a sub 3, a sub 4, and a sub 5. Go ahead and write them out. Okay, Seth, what did you get for your first term here?
8.
Yeah, 8. And how'd you get 8 again?
Multiply 1 by 3.
Yeah, just
3 plus
yeah, plug in 1, out comes an 8. Then what's the next term?
11.
11, next term.
14.
Next term.
17.
Next term.
20.
20. Okay, good. Is this sequence arithmetic? Yes or no?
Yes.
Okay, what makes this sequence arithmetic?
The difference is
Yes, because the difference, they have a common difference, which we call 3 in this case, right? If I take any term, let's say this term, and I subtract off the previous term, 17 minus 14 is 3. That number is constant throughout the entire sequence. How do you guys feel? All right, I've given you 2 sequences here. Determine which of the 2, or both, are arithmetic, and then say why or why not at your table group right now. Yasmin, you say yes?
Yeah.
Why do you say yes, Yasmin?
Because it's -1.
Because the common difference here is a -1. We're adding -1 each time as we go down the sequence, okay? The second one, Cindy, what'd you get? Why'd you say no for this one, Cindy? Because there's no common difference. Yeah, the difference between this one is 1. The difference between this one would be 2. This one goes up by 4. This is a different type of sequence. We'll talk about that later. Not arithmetic. This one is, and the difference was -1. So yeah, it is possible for our differences to be negative. All right, so I told you that arithmetic sequences are recursive. That means that they build off one another, and that means you have to know something about the previous term to get to the next term, right? But arithmetic sequences are a special case, and because the difference between every 2 terms is always the same, we have the ability to sort of fast forward through the sequence to get to any term that we want to. So as an example, right, what would be like the 23rd term, I wonder? Well, I sure as heck would not want to find all the terms in between. That would be a big waste of time. Instead, we are allowed to use the fast forward formula. And here it is. I'm going to do hot pink for you. Okay, so a sub n is equal to a sub 1 plus n minus 1 times d. So let me tell you what all of these pieces mean. A sub n is the term you're looking for, or the term that you want. A sub 1, of course, is the very first term. The n minus 1 means that, let's say I want the 10th term, then n minus 1 would have to be 9. If I want the 50th term, then n minus 1 would be 49. So number of terms minus 1. So that's just number of terms minus 1. And then d, of course, is your difference. So this only works for arithmetic sequences. So let's apply this formula to this case right here. So I'll move over and we'll go green. If I want the 23rd term, and I realize that this sequence is arithmetic, I can apply the formula. The first term, which is what, everybody? 8. Very good. Plus, I'm going to have 23 minus 1. And then what's my common difference? How do I go from 8 to 11? I go up 3. 11 to 14. Up 3. 14 to 17. Up 3. So the difference is 3. So therefore, the 23rd term has to be 8 plus 22 times 3. So the 23rd term is going to be 8 plus, what is that, 66? So the 23rd term, the thing that I want, the term that I want, has to be 66 and 8, 74. Awesome. So therefore, we now have fast forwarded all the way up to the 23rd term and found that that term is a value of 74. All right, so here's a sequence. Yeah, it's a U-try. Absolutely, U-try. Very good. All right, so given the arithmetic sequence 2, 6, 10, yada, 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 what would be the 207th term of that sequence? I sure as heck would not want to have to find all those in between. Use the fast forward formula and come up with the 207th term. All right, so you guys come up with 826 for the 207th term? Everybody didn't get that? Sarah, everybody else got that? Everybody good? Okay, so we can use the fast forward formula. We can fast forward up to where we want. Okay, next idea. All right, so giving you an arithmetic sequence, I'm telling you that the sequence is arithmetic. If you know the 8th term is 75 and the 20th term is 39, how can we get the first term of the sequence? So if we were going to lay this out, okay, here's a sub 1. That's the thing that we're looking for right now. And then if we keep going down the sequence, we know that the 8th term is 75. And if we keep going down the sequence, we know that the 20th term is 39. All right, so we got to be able to figure out how to get the first term. Well, the good news is about arithmetic sequences is that that common difference stays uniform throughout. So if you think of a sequence as a line, this would be linear, and all linear lines, well, obviously linear lines, they would have slopes, right?
Does it a sub 8?
Yeah, this is a sub 8. I know it looks kind of silly, huh? Here we go. There, is that better?
Yes.
Great. Now that we know that, how do you find the difference for this? What would we do?
All this as is recorded.
So essentially, we use the slope formula. So this is like y2 minus y1 over x2 minus x1. Remember, an arithmetic sequence is an input-output, right? Just like any other sequence. So if I put in an 8, I would get out of 75. If I put in a 20, I get out of 39. So we can use the slope formula to determine that difference. So I'm going to go ahead and say that'd be 39 minus 75 all over 20 take away 8. All right, 39 minus 75, what's that? I got negative 36. Over 20 minus 8?
12.
12, awesome. So we're getting a difference of what? Negative 3, awesome, there you go. So our difference is a value of negative 3, that's okay. So should we expect the first term to be greater than or less than 75? Yeah, greater than, right? It's going down, our difference is going down. Okay, good. Now that we know the difference is negative 3, we have to use one of these points. We can either use this one or we can use this one. Which one do you want to use? Doesn't matter to me.
Let's do 39.
All right, let's do 39. So here's what we know. We know that a sub 20 had to equal the very first term plus 20 minus 1 times our difference of negative 3. Well, a sub 20 is a value of 39, huh? So 39 has to be a sub 1 plus 19 times negative 3. All right, so that means that 39 has to be a sub 1 minus, what's 19 times 3? Anybody got that one for me? Negative 57. Awesome. And what am I looking for, you guys?
So looking for a sub 1.
Yeah, I'm looking for a sub 1. So let's add that. Nice job. Whoa, where'd you go? So there you go. A sub 1 would have to be 39 plus 57 on a good day. 96. There we go. So in the very first term of this sequence we've just figured out had to be 96. So it turns out we are allowed to add these sequences up, and we can actually get an actual answer using the sum of a finite arithmetic sequence. What does the word finite mean before we continue though? Not infinite. Yeah, that means it ends somewhere, right? Okay. So here's what we're going to use. The sum of the first n terms of our sequence, the sum of the first n terms, will be the number of terms divided by 2, multiplied by the first term plus the last term. So this is also super important for us today. So let's talk about what each piece means. So this says the sum of the first n terms has to be number of terms divided by 2. Number of terms divided by 2. This one is your first term. And this one is your last term. Okay, here is an arithmetic sequence. And write out the first 4 terms of that arithmetic sequence. Write the first 4 terms out in your table group. Okay, Yasmin, what'd you get? 5, 7, 9, 11. You guys agree with that? Yeah. Okay, 5, 7, 9, 11. Okay, good. What is the 40th term? What's the 40th term? How would you do it? Just plug it in. So what would it be?
It would be 5 plus.
No. There's a faster way. What's the 40th term, guys? 83. Yeah, 83. How'd you do that so fast? Yeah, just plug in right there, right? Plug in a 40 for that. Okay, good. Now, ladies and gentlemen, let's add these all up. What would you get if you added up the sum of the first 40 terms? The sum of the first 40 terms? Would be 40 over 2. First term would be 5. Last term would be what? 83. Awesome. So the sum of the first 40 terms would have to be 40 divided by 2. All over 85 and 5. How much would that be? 88. There we go.
Why did you replace A with that?
So we confirm that we got 1,760.